So hello everyone, welcome to this another video of Scale Up India. In this video we are going to talk about lambda expressions in Java, or the popularly known as lambdas. So directly let's move to what's a lambda expression. This time we are not going to cover why do we need a lambda expression, because that you will automatically come to know when we will start our coding. So let's understand what's a lambda expression. So as per the definition, a lambda expression is a concise way to represent an anonymous function which can be used as a functional interface instance. Now if you don't know what's an anonymous function, then just assume it's a method in Java which don't have any particular name. And what is a functional interface? So that you will come to know very soon. They also say lambda expressions were introduced in Java 8 to support functional programming concepts and improve code readability and conciseness. So this you will directly come to know when we will be starting our coding part. Now let's see how the lambda expression looks like. So it looks something like this. First of all, in this particular brackets, we have our input arguments, whatever the input for the method. Then we have this arrow symbol which popularly represents the lambda in Java. And then we have the body of the method within these curly braces. So this is how your lambda expression looks like. Now let's also understand what's a functional interface. So a functional interface is an interface that specifies exactly one abstract method. So as you know that functional interface can have any number of abstract methods, it can have any number of default methods, static methods, private methods also. But here when we are saying it's a functional interface, then we mean to say that one and only one abstract method is allowed. What about default? What about static? And what about private methods? So they can be 0, they can be 1, they can be more. But about abstract method, it can be one and only one, not more than one, not less than one. And then only we can write a lambda expression for that particular functional interface. So you cannot write a lambda expression for any other class or for any other normal interface. Also, in order to define a functional interface, we generally annotate it with the @functional interface annotation, although that is not mandatory. So it simply tells the compiler that if you will try to add a new abstract method, then it will give you the compilation error. Otherwise, this is not mandatory, but although it's a good practice if you are creating a functional interface. Now let's directly jump towards our IDE and see everything in the format of code. So here we are in our IDE, and let's move on towards our demo one. So this demo has been created with JDK 17 as always, and let's directly first of all see the theory behind this. What is the story? What is the scenario we are going to cover here? So here we have 3 packages looking something like this, and first of all let's go to this service package which contains an interface which is the operation. So in the operation interface we have a very simple method here, that's the increment method. Here we are going to pass one particular integer, and this is also going to return you an integer. Simple, nothing difficult. And this is going to be the implementation for that particular interface. So we are calling it by the name of operation IMPL, and then we are overriding this particular method. And since it's an increment method, so we just need to add 1 to the number and return it. So here we are going to do something like pre-increment, and we will say plus plus num. So if you are going to pass 10, it will return you 11 and so on. So now let's move to our test1 class, and here we have some particular task to be done. So first of all they tell us to create an object of operation. So let's do this. So this is operation, and let's call the variable as operation, and here we will be saying new of operation, something like this, and that's it. And let's say Ctrl+Shift+F so that it does the importing, and we need to import from here, and we are done. But just read on. Here we are getting some particular compilation error, and the reason is because we are using the new keyword directly with our interface. And as you know that in Java we cannot instantiate the interface directly, and hence how we can do so? By making an implementation class, something like this operation IMPL. So what we will do is, instead of saying operation here, let's say operation IMPL, and again let's say Ctrl Shift O to import this thing. So this is done. Now they say invoke increment method and save the output in a result variable. Okay, let's do that too. So we will be saying this operation and then we'll say dot, and here we are going to call the increment method, and here it is. And the output is going to be an integer. So let's save this integer in a result variable as asked. So it looks something like this. So we have passed on 0 here and we are getting the result. And then they say that we should be printing the result variable. So let's do that too. So here is a sysout, and here we are going to print the result variable. So that's it. As of now, we have not even started with the Lambda. So this is just a normal Java coding. And let's execute this and see what should be the output. Obviously, it should be 1 if everything is working fine. So let's see this. So yeah, as you can see, the output is 1 here because we have passed 0. So it incremented and output is 1. If I pass 10 and then again I execute this, so let me say always save resources before launching and say OK. So it is going to provide me 11, which is fine now. Now let's try to understand that what we did here. So here we just created first of all an object of operation interface. Now since operation was interface, it was not possible for us to directly say new of operation, and hence we need to say operation IMPL. Now let's try to understand what is the sole purpose of this operation IMPL class. The sole purpose of this operation IMPL class was only that you can provide an implementation to the operation interface, so that we can have some kind of implementation to this increment method. Otherwise, there was no usage of this operation IMPL in our whole scenario, which is simple. So let's do something like this. What I'll do is I'll copy this test and let me create another class out of this. Now let's close this test 1 and do test 2. I will be uploading all these demos in the same way to the GitHub, and from there also you can download it in the same order and you can execute on your own. So as I told you, the only purpose of operation IMPL is to provide the implementation. So what if we don't provide the implementation in a separate class and we just copy this implementation? So let's copy this. This is the implementation. Let's go here and just directly put it after this. So after this bracket and before the semicolon. So we are keeping it here. So this is the one. Now we don't need to go for operation IMPL. So let's remove that and this should work fine. So now as you can see, what's happening here is that we are directly able to create an object of operation. We are directly able to instantiate the operation interface, which is magical. But it's not that magical because the problem for this earlier was that we were not having the body, and this time we are directly having the body here. So what do we call this? This is known as anonymous class. So since this particular class doesn't have any name, if you will say that the name of this class is operation, then you will be wrong, because operation is our interface. If you will say this is operation IMPL, then again we are wrong, because now I'm not using operation IMPL anywhere. Hence, we'll say this is a class but without any name. So this is anonymous. And since this class is already within another class, which is test2, so we will say this is an anonymous inner class. So let me just write here. So this is your anonymous inner class. Hope my spelling is right here, and okay, it seems to be right. I guess one N is extra. Now it is fine. So this is your anonymous inner class, and this is simple, and you can do this any point of time. Now you don't need this extra operation IMPL, and this should do your job. let's just execute, and before that let's do Ctrl+Shift+O so that we don't have the import of operation IMPL. So let's execute and see if this works, and let's choose Java application, and yeah, as you can see, this is working fine. If you have any doubt, let's change this number to 20 and let's execute it again. So this is again working and we are getting the output as 21. So this simply works fine. Now let's do something more interesting, and let's copy this test2 and make something like test3 now. So here we are in our test3. We don't need operation IMPL. Let me close that, and this operation is there, so let's have it there only. Now let's try to dig more into this. So here, what do you think? If on this particular side, that is the left side, if I say operation, on right side, can I write anything? Can I say operation 2? Can I say operation 3? Or something like this, operation 8? The answer is no. This is not possible. If on the left side we have operation, now then on the right hand side we can only write either the child class of operation, or we can write the same operation itself with the body. Since we are providing body here, we can't even write operation IMPL, and we need to write this only. So in this case, when we also know that we can only write operation, and Java also knows that we can only write operation, then why to write this? So let's remove it. So we will remove this operation as well as these brackets of it, so that we have removed. Now let's save it. So currently it's giving a compilation error, but no need to worry. We need to discuss few more things here. Now everybody knows that in the operation interface there was only one method, increment. So it is not possible for us that we can override any other method. I can't say that I will be overriding a decrement method or add method or plus method or any other method. I just need to override the increment method here. So if we also know we need to override the increment method, Java also knows we can override only that method, then why to tell or why to write this same thing again? So let's remove the annotation. Let's remove this public also, and everyone knows it needs to return int only. There is no other option. So let's remove this too and all these things. And now it looks something like this. So this is your input argument for the method, and this is the body of your method. And between the input argument and between your body, let's put a arrow for the lambda, which looks something like this. And now let's do something more also. We don't need these braces, so let's remove them, because these braces for the class. So now we don't have that class, so let's remove that. So here we have removed those braces, and let's remove them from here too, and the semicolon will appear here, and we will just do something like Ctrl+Shift+F and format this. So now it looks something like this. So this is the input of your method increment. This is the body of your method increment, and this is just the arrow operation for the lambda. And now this is your lambda expression. So if you remember, in the PPT also I shown you something like this: the input, the arrow, and the body. So this is how the lambda expressions get generated. So I hope you have covered this. Now let's check few more things here. We can even make it more shorter than this. So again, everyone knows that the input should be an integer only. There is no doubt. You cannot pass a string, you cannot pass any other number, because then it won't be considered as overridden. So when again everyone knows, no need to mention. So let's remove that too. Now why do we use brackets? We generally use brackets when we want to depict that okay, these particular things are clubbed with each other. So there is no need to keep brackets around a single thing. So no need to keep this thing also here. So let's remove, and this is still your lambda expression, but even more shorter than that, the previous one. Now If you remember that when we were studying about the conditional things, the if-else logic, when we were talking about the loops, while condition, for loop and all those things, at that point of time, I used to say that if your block has only one statement, then you don't need braces. So here also, when our body is having only one statement, that is return plus plus num, we don't need to have these braces. So let's remove them too. Now, when you have removed the braces, rule says you should not have the return also. So if you don't have braces, you should not use the return keyword. So let's remove that too. And let's again say Control Shift F. And this is an extra semicolon. So let's remove that too. And now it looks something like this. So this num is your input integer and this plus plus num is your output, or you can say this is going to be your body of the expression. And now we can say this is the shortest possible lambda expression which can be written for the previous class. So this is the one, and if you wish I can just execute this one. Let's say Java application, and yeah, this is working fine. If you wish I can even make it 30, and now also again if I execute, this is still working fine. So you see how we have removed the requirement of one whole class, and the same thing we are just doing in a particular single line, and hence we make usage of lambda expression, because what it has actually done is it has made your code precise and short also. Now you don't need one whole extra class. So you are decreasing the burden of Java here, because you know that for every .java file, Java creates a .class file also. But since now we are not using the operation impl, so there is no need to create a .class file for that, and only this much works. If you will say, is this a class? The answer is no. This is just an expression, a lambda expression, which we have written here. Now, there can be a question that what if we have multiple methods here, that currently everyone knew only increment is there, so hence we were able to write. But what if we had something like, let's say, decrement, which also takes an integer num, and this one. So then also, can we write this lambda expression? Or okay, the spelling is wrong, but nothing to worry. So the answer is no. In that case, we cannot write a lambda expression. So if you remember what I mentioned in the PPT, lambda expression can be written only and only when you have the functional interface. And the rules of functional interface were one and only one abstract method, not more than that and not even less than that. So if I remove this one completely, then obviously what will you implement if there is nothing? So even that is not possible. So we can write a lambda expression only when it's a functional interface. So this operation, if you see, this is your functional interface. And if you wish, we can even override this, or we can even not override, but basically we can write this in annotation as functional interface. So we have made it something like this. And now even if by mistake someone tries to, let's say, create any other method, let's say even something this one, so then it will just simply throw the error here only, and the error will say, let's see what it says. So okay, let me make it num2 first of all. And now this error says that invalid functional interface annotation, operation is not a functional interface, because if you have created another abstract method, then it's no more a functional interface. And what about your default methods, static methods, or private methods? Yes, you can have any number of those methods in this particular interface, but one and only one method of abstract. Also, in order to remember this, we take help of our friend Sam. Sam, if you know, simply says single abstract method. So let me make this M as capital. So this is your single abstract method. So I hope now we are clear how to create a lambda expression, not directly but with a particular step-by-step approach. And now you also know that how we have derived two particular lambda function. So from Java 8 onwards, since it was introduced there only, before Java 8 we couldn't have even written something like this. But now onwards, I hope that you will start using these lambda expressions and you are going to make your code simple and short also. And don't worry that if you say that okay, this was just one demo, what about others? So we will have few more demos about this and we are going to practice the same thing again and again. Hence, in this video itself, you are going to become an expert of the lambda expressions. So this was just one example. Now let's move ahead with our next example. So let's go to demo 2. Now in demo 2, again we have something like this. So we have this operation, but this time it's a little different. So this time we have an input number. The method is positive. The output is a Boolean value. So only true or false. Then we have this operation IMPL and we say if number is greater than 0, we will say true, else we will say false. Let me make it greater than equals to 0. That for 0 also it says positive only and not negative. So now this is more better. Now let's go to test 1 and here what we are doing. So we have obviously done this particular thing. We are saying new of operation IMPL. Then we are calling the isPositive method. We are passing 10 and we are printing the output. So it should be as true. So here we are getting answer as true. Now first of all we will create an anonymous inner class for this and then we are going to create a lambda expression for this step by step. If you wish, you can also pause the video and you can directly create a lambda expression and then you can compare with mine. So let's get started. So we don't need this operation IMPL as of now. Currently we need, because we need to copy. So I'll copy this test 1, make something like test 2 so that I don't need test 1 here. Let's go here. Let's copy the body from this one. So we have copied the body. Let's go here. Let's write something like this. We don't need operation IMPL now. So that's not required. And now it looks something like this. So this is again your anonymous inner class. Always remember to put this body after the brackets and before this particular semicolon. So we went here. Now let's copy this again and create a lambda out of this. So here we are in test 3. Let's go and this is the one. So let's start creating. Again, let's repeat the things so that it becomes obvious for you also that how to create a lambda expression next time directly. Everyone knows first of all that here it is operation. So here we can't write anything separately. So if you wish, you can repeat with me parallelly. So this is operation. Java also knows, we also knows. Hence we should not write here operation again. So this is removed. Now this was the body of your class. So we don't need this also. And hence I'm doing from here too. So now it looks something like this. Now everyone knows that only this particular isPositive method can be overridden. Output is Boolean. And hence we should not again mention the same thing here. So let's remove this part too. And then this is your input. This particular part is your body. And between them, let's put an arrow symbol. So this becomes a lambda expression. Let's do Ctrl+Shift+F and it looks something like this. If I execute, let's see if this works or not. So yeah, this is working fine. The answer is true. If I make it -10, let's check out again and the answer is false now. Now, everyone knows that only integer was the input. So no need to mention it. Since there is only one particular argument, no need of brackets also. So let's remove that too. Since there was only one statement, no need of braces. Now if you don't write braces, no need for the return keyword also. It's a rule. Otherwise it will give you the compilation error. So we have removed that too. And then there is again no meaning of having two semicolons together. So let's remove one of them and let's say Ctrl+Shift+F. So this is your again a lambda expression for that particular operation IMPL class. So this is your input number and this is our body, and if I execute this, so again I will be getting answer as false. So this is also done. Now we know how to return a Boolean also. Last time we did how to take a integer input, how to return an integer input. This time we have learned how to take an integer input, how to return a Boolean. And it's not the case that you can do it only for the integer. You can do with any kind of input type. You can do with any kind of output also. So now let's move on with our third demo here. And let's repeat the same things again. So here we are in the operation. This time input is an integer, print method. The output is void. So this time it is not returning something. So this is going to be little different. Let's see. This is your operation IMPL, which says you are learning Java hyphen and then whatever the version you are learning, that version it is going to print. So it is just a sysout statement. This is your test one, and if I execute this, it looks something like this. You are learning Java 17. Here we don't need any kind of result or any kind of sysout again, because print method is obviously having a sysout on its own. So let's copy this, create test2 class, close test1. Let's go to test2. Now let's copy the body of this particular class. The whole body we have copied here. Let's keep it after the brackets before semicolon, something like this. Now we don't need that particular thing. Now again, we don't need operation IMPL. We can write something like this, which is your anonymous inner class once again. So let's save it and let's try to execute this one. So if I see Java application, it will again give me the output. Let's say Ctrl+Shift+O, so to remove that import. Now copy this test2 and create another test3, something like this. And now again let's repeat. Everyone knows it's an operation, so no need of this, and no need of these body braces also. So let's remove that too. Now everyone knows it's just a print method, so no need of this particular part also. Now this is your input and this is particular your body. So let's put an arrow between these and say Ctrl+Shift+F. So this is your lambda expression looks like. Now we don't need braces because it's just a single line. So let's remove that, and let's remove that from here too. No need of this extra semicolon and this extra line. So let's say Ctrl+Shift+F, and it looks something like this. Can we make it even more simpler here? The current answer is no, because this time there is no return, so that you can't remove. But yeah, we can remove this int and these braces. So let's remove that, and it looks something like this. So this is the lambda expression, and this is the simplest possible as of now. As of now I'm saying. Later on maybe we can make it even more shorter, but this is the one here. So this is again how it looks like, and currently it is not returning anything. It is just printing. So if you have a sysout, automatically it will come to know it is not going to return anything, and this is how this is going to work for us. So this is also done. Let's move ahead with the next demo. So I hope by now you have got more control over this. So this time it's again different. This time there we don't have any kind of input. We just have a return type, which is a local date time. So if you are not comfortable with the local date, then also no need to worry. Just assume that here we are returning a particular instance of class and we don't have any input. So that is the scenario. This is operation IMPL, and this is the way how you can create a current instance of local date time. And again, this local date time was introduced in Java 8 only and not before that. So we can go for local date also, but let's go for local date time. So this is our test one. Let's execute this first of all quickly. And this time you see that I'm creating this video and creating this demo on 19th of May 2023, and the timing is 10:52 AM. So this is the one. Let's copy this, create test2 out of it, and let's go here. Now again let's copy the body and create an anonymous inner class. So here we are, this one, this is the point, and let's execute. So now as you can see, again it is the same, only some seconds different. So this is also working. Let's create the lambda also from this. So this is your test 3 here, guys. So in the test 3, again we don't need this operation IMPL, and I guess I missed from removing from here. We should not write that since we are not using it directly. So here let's say this as operation only first of all. Now this part is common, so let's remove, and this time I'm going to remove this also together and even the method name. So all these things I have removed. From here I will make it something like this. Now this is my input and this is my body, and between them let me keep a arrow here. So now it looks something like this. Now only single statement, so no need of braces and hence no need of the return keyword. So let's remove that also, and now it looks something like this, a shorter one. Now what if, can we remove these brackets from here? This time the answer is no. Now you can't remove, otherwise it will look something like this, which is going to be very odd here. So this is not even good in looking. So hence we need these brackets here, so that we also understand and Java also understand. So now onwards we and Java are on the same level, guys. So both of us are friends, so we should understand each other. Java should understand us and we should understand Java in a better terms. And if I execute this demo, so it looks something like this. So again this is done. So here we have covered the scenarios where we were having an input integer and output integer. Then we covered input integer, output boolean. Then we covered input integer, output void. And this time no input but some particular output as local date time. So this is working again fine. Let's move ahead with the next 5th demo. And this time I'll be trying to become a little bit more quick. Okay, but this time it is little different. This time we have 2 input arguments and not a single one. So here we have something like num1 and num2 and the method is divide. Okay, let's tackle this too. So this is how the operation IMPL looks like. We are just dividing, and this is how the test 1 looks like. And if I execute with the input as 10 and 5, I will be getting output as 2. So this is fine. Now what I'll do is, again I'll create something like this here. Since we will be doing with 2 arguments for the first time, let's first create the anonymous inner class. I know you are already bored with doing the whole thing again and again, but it's good to have that much practice. We don't need IMPL, so it looks something like this. So this is fine, guys, and let's execute. So answer is again 2. That is also good. Now let's have a copy of it and create something like test 3. We don't need operation IMPL now, so we are here. Now again this part is common, so let's remove. Divide method is there, so let's remove. From here also we don't need this particular thing, so let's remove. Now this is your input and this particular part is again your body, so let's have an arrow between them, and let's say Ctrl Shift F. So this looks something like this. Now first of all let's talk about this part. Again there is a single statement, so no need of braces, no need of return keyword, and no need of this particular thing also. So this is also removed. So this is how your lambda expression looks like. Can we remove data type now? The answer is yes. So even if these are multiple arguments, we can still remove the data type, because again it is not possible that you can say here string. You need to have it to be an int only, because in the interface it was int. So this is mandatory, hence we should not even write here int, and we should remove them. So I have removed both of them, something like this. So this is the one. So both of them have been removed. Now can I remove these brackets this time? The answer is no, because again remember, why do we need these brackets in general? To club something. Now if I remove this, your code will look something like this, which is going to be very odd here. So it is going to be difficult for you also to understand and for Java also. So why do we get confused? Because it may appear that okay, num2 is the input and this is the body and num1 is something different. So let's not get confused and keep these brackets here because they are required. And if I execute, the answer is still 2 here. So this is the one. We will come back to this demo again after some time in our demo number 8. But before that, let's understand few more things. So let's close this. I hope this is also clear. Let's go to demo number 6 now. So there we are. Now here, let's again see what do we have in operation. Okay, this time 2 numbers, output is Boolean, and this is your IMPL, this is your test1. So we don't need to execute. We know that okay, 10 is greater than 5. The answer is going to be true. Let's directly create a test2 class here by repeating the steps again. The more you repeat, the more it is going to become obvious, and the next time you won't make a mistake. So let's do this directly here, something like this, and let's remove this operation here. So this is the one and how it looks like to us. So this is fine again. Now let's again have a copy of this and let's create a test3 class. So we are here. We again don't need operations. So let's remove this. Let's remove this too. All these things are removed. From here we don't need this braces. So let's remove that too. And here we need a arrow. This time fine. We don't need this braces and the return keyword. So let's remove this and let's remove this too. We again don't need integer, but wait. Can we have something like this, that I am removing only one data type but other data type I need? The answer is no. You can't write something like this. So the rule says if there are multiple input arguments, then either keep all of them, something like this. So if you write this, this is a lambda expression, or you remove all of them. But you can't say that I will keep some, I will remove some. That is not a good practice, because then Java will get confused. And if Java is confused, you know very well it is not going to return you any output. So this is going to work fine now if I execute, and the answer is true because 10 is greater than 5. So this works. Great. Let's move on with our next demo quickly. So here we are in the operation, and this time 2 inputs, void as the output, which means we don't have any output here. This is operation IMPL. This time the language also we will be taking, then we'll put an hyphen and then we'll put a version here. Okay, this is your test1. Obviously this is going to work fine. So let me directly go here, and this time let's try to create the lambda expressions directly instead of anonymous inner class. Let's see, are we comfortable with that or no? So let's assume we don't have something like this, and we just have a semicolon here. Now what do we need first of all? First of all, we need input arguments. So we'll just write here. First one was a string. So let's say string language. If you wish, we can even change this particular thing, but just for the readability I'm making it something like this, an int version. So these two were your inputs. Now you will say, do we need the arguments? They are going to be different, but still we don't need them. So let's remove. We just need our brackets and the 2 inputs. Then we need a arrow here, and then what do we need? We just need the statement within the body. Since it's a big one and I'm a little lazy, so let me copy this. So I have copied it and let me just paste it out here. So this is how it looks like. We have directly created the lambda expressions without the need of anonymous class also this time. And if I say Ctrl+Shift+F, so it will look something like this, but that is not an issue because this is just a formatting of your Eclipse. If you are facing difficulties in understanding this, you can again make it something like this. So for this you need to scroll a bit. So if you're fine with that, then also it's good. If you are not fine with that, then you can say Ctrl+Shift+O and then you can make it in that way too. But currently I'm fine with this. So if I execute, let's see if this works or not. So yeah, this is going to work fine. You are learning Java 17 here. So this also works fine for us, and we were able to do without the requirement of our anonymous inner class. So this means now we are even much more comfortable. Now you will ask me, can we do this with 3 arguments, 4 arguments? The answer is yes, you can do. If you say, what if we have multiple statements in our body? Then also it is fine. If you wish, you can have multiple statements in your body. There is no issue with that. But the point is, for the multiple statements, you need the braces mandatory, because then you don't have an option to remove them. Generally, we write lambda expression for the single statement because then it becomes even more shorter. But there is no harm for the bigger one also. At the end of the story, your code should be small and understandable to you also and others also. That's the only point here. Now let's move on with the next demo, guys. That's demo number 8. So in demo number 8, let's see what do we have. So here we have something like this. Okay, but we have already done this. We have operation IMPL and we have again done this. And here we have test 1, which again we have done. So what's the difference this time? Let's see. So the difference is this time we are going to pass a 0 here, which means we will be getting an exception. So let's see how Lambda can handle this exception. So for this, what we will do is, again, let's create this one, test 2. And in the test 2, what we will be doing is, let's try to create it directly. So this time again we just need 2 inputs. So here we need a num1 comma a num2. So that's the thing. Then I need an arrow which is there, and then I just need to return a single statement. So I will say num1 divide by num2, and that's it. Let me say Control Shift O, Control Shift F, and this gets formatted. Let me close this. Now again, if I pass 0, will it return me the exception? The answer is yes. This is returning me an expression now also. So this is working fine, which means that your Lambda expressions can return the exceptions also. There is no harm in that. So this one looks good. Now next, what if that here I don't want to throw this arithmetic exception, and instead I want to throw some other exception on my own? So for this, what we will do is, we will say here if num2 equals to 0, and let me say here something like how to throw an exception. I hope you have watched my video on exception handling in Java, where I show how to throw an exception on your own also. And if not, then I hope you can directly click on the I button on top and you can watch that video also. But let's do this part quickly here. So we'll say throw new, and let's return something like null pointer exception. So here we will say null pointer exception, and in the body, that in the message, let's say our custom message. Again, I'm making a mistake. Okay, this is fine now. So we'll say cannot, and let's keep this C as capital. So we will say cannot divide, and now I want to say cannot divide num1 by num2. So I will say like this, cannot divide num1, then I'll say plus, then I'll say by, and then again I will say num2. So obviously this will work only when num2 is 0. So every time it will say cannot divide num1 by 0. So this is fine. Now let's execute it with this test2 again. Let's see, will it work or not? So you can see this is not working. So what is the error here? So the error here is that we have made changes here. So we need to execute test1 first, because that is making usage of operation IMPL. So let's execute. So you can see this time it is not arithmetic but a null pointer exception, and this is our message, cannot divide 10 by 0. Okay, so this one looks fine here. Can we do the same thing with this particular lambda also? So yes, we can do that, but the point is now our body looks something like this. Now it's little bigger than the previous one. So we can't simply write a single statement. We need to copy the whole and we need to replace it here, something like this. So if we write this, now this is going to work fine. And yes, your lambda expression can look something like this too. This is still a lambda expression because this is your input, this is the arrow, and this is your body. Now you can't say that I don't wish to write the braces because there are multiple lines. Otherwise, how will Java understand all these are together with each other? So yeah, this is also working fine. A null pointer exception is there and it says cannot divide 10 by 0. This looks good. Now, instead of null pointer exception, what if I wish to throw any other exception? Let's say I wish to throw IO exception. So will this work? The answer is this is not working. But why? Again, for this you need to watch my video on exception handling, because then only you will come to know why it is throwing error for this one, a compilation error, because IO exception is a checked exception here. Hence, you need to explicitly tell Java that this method can return integer as well as it can throw IO exception, and that you can do by writing something like this: throws IO exception. So this is fine. But why is it still giving you the exception? Because the rule says the overridden method cannot throw any new checked exception. So in the parent also you need to mention that it can throw a checked exception. So let's mention there too. So this we have copied. Let's go here and let's put something like this, Ctrl+Shift+F. So now this is fine, throws IO exception, and this is your this one, throws IO exception. This is again fine. Let's go to test 1, and this time it says there is an unhandled exception, so it should be handled. So how we are going to handle this is we will write a try catch block on this. So we will say try, and let's keep everything in our try block, and let's say something catch. If you wish you can handle this, or if you wish you can handle the general exception also, which is E, or let's write the whole name for the good practices. And what do we want to do? So let's say we just want to print the exception itself. So we will say exception object, something like this, Ctrl+Shift+F, and let's execute this. So now there is no issues because test2 was having issue, but that we are going to check. So now what will happen is it will go to operation IMPL, it will go to your divide method, which is here. This time it is going to throw the checked exception. So that has been thrown, and since we are handling it, it doesn't print this particular statement and instead directly goes to your catch block, and there we are going to print the exception. Now you know when we print exception, it gives the exception name as well as the message in this particular order. How it does for this, you need to watch the video on exception handling. Now let's move ahead and do the same thing with our test2. So with the test2, how can we do here? So here we can say IO exception, and this looks fine. So yeah, this is only you need to do. Now you don't need to mention here something like this, throws IO exception. There is no need of it. In the parent you have already mentioned, so you don't need to write here explicitly. Now obviously you need to have a try catch with the same way. So we will say a try, and here we are going to say a catch block. So I'm again a little lazy, so let me copy the things from here. So as a coder you can be little lazy sometimes and say Ctrl+Shift+F, and if I execute this, this is going to throw me the or return me the same kind of output, that it's an IO exception and I cannot divide 10 by 0. So it looks fine. So now we have learned how to handle exceptions also, checked as well as the unchecked, both kind of exceptions. So the next topic is important functional interfaces. So till now we have seen the functional interfaces, but those functional interfaces were created by us. Yeah, and hence we were making them. But what if Java can also provide us some functional interface? Yes, Java can provide us many functional interface, but there are few which should always be on our tips. Why they should be on our tips? Because after this particular video, in the next one we are going to talk about streams, and streams are going to make usage of those functional interface. So there are some default functional interface which are very famous also, and we should have some basic idea about them. So again we are here, and for this instead of going for any new demo, we will go back to our demo one again. So don't feel that why this video has restarted. So it's not that case. So let's revise what we did. So we will directly go to our test3 class, and here if you remember, we used to have the operation functional interface with the method increment, which can take input integer and can return an output integer. And this is the way we have written this particular thing. We don't need this operation IMPL now. Now let's do the same thing with the help of a functional interface. So what I'll do is I'll copy this test3 and I'll write it here and say test4. So I'll go to this test4 here this time. Again, I don't need operation. Now instead of operation, what if Java has already created some method like this? Because try to understand, why do we created this interface? Like last time we just talked about why did we created that class and we removed it. So this time, why did we created this particular interface? Because we wanted to have a functional interface. We wanted to write a lambda expression which can take an input integer and can return you the integer number itself, or in short, which can take something and can return something. So for this purpose, why do you need an operation? This is such a common practice. I want something like this, you want something like this, maybe someone else also wants something like this. So Java says, okay, let me provide you this interface on my own. So for this, Java says you don't need to create operation and you can just make usage of function. So we will write here function. I'll just say Control-Shift-O instead of this. Now this is imported, and what I'll do is I'll take my cursor here and I'll say open declaration. So this is the function, which is a functional interface. So please don't get confused. Functional interface you already know, the interfaces which have one and only one abstract method, and the name of that interface is function, which Java has created. Now they are doing this because they don't know what you want to give as input, what you want to give as output. Hence they made it a generic interface. Now again, if you don't know about generics, then you can watch that video. Already that video is having very less number of views as it should have. So please watch it, give some views to that videos, and you will get very good idea about generics also with that. So the abstract method which it has is apply. The first T represents the input type and this R represents your return output type. So T here stands for input, R stands for the output here. This is apply. Besides this abstract method also, as I said, your functional interface can have other methods too. So you can see some other methods are also there. As of now, we are not going to discuss about these static and default methods. Our main concern is this abstract method only. So this time, instead of using operation, we will be using function. And instead of using the method increment, we will be using the method apply, which can, for in our case, it should take an integer, it should return an integer. So let's see here. So this is function. Now we need to say it will take integer. So here we will say integer. Now again, I can't say int here because generics don't accept primitive data types. So it takes integer input and it gives you the integer as the output itself. And yeah, the rest of the things are fine. You don't need to make any change in the lambda expression. Same, it worked here fine. And this time we should not call increment because this method is not available. Instead, the method name is apply. So yeah, that's it. This time we don't even need the operation. So this is that simple. So let me remove this statement. Let me remove this particular statement. Let me remove this particular statement too. So this is how we can directly make usage of functional interface. So you see, we didn't even created a class. We didn't even created an interface. We just need to create a lambda expression and Java will provide us. Now this function is a very important functional interface which we should remember. Now what all things you need to remember? The name of the interface, which is function. What it does, it accepts something, it returns something. And what is the method? Apply. So all these things should be on our tips. Now let's go to demo 2 and see what do we had there. So in the demo 2 we had something like this operation, and this used to, what it used to do, it used to accept an integer and return a boolean. So we can replace this too. So let's try to replace in our test 4. So here we are, and let's try to replace. So again, can I go with that same function? The answer is yes, I can go with it. I can say Control Shift this, and this time it takes an integer. This is integer, and the output should be a boolean with B capital, so that it represents a wrapper class to us, and this much is sufficient to us. And here the method is apply. So let's say apply here, and yeah, this looks good. Let's just execute it quickly, and this looks again something like this, and the output is false because we have passed -10 here. So function works for this too. So you see, same function can work for the previous one also, this one also. Hence you can have anything as input, anything as output. Just remember here that this should be same as this input, the data type, and the output should be a boolean or whatever you have mentioned here. But now Java says that this is again a very, a common concept. I mean, how many times we need to take such decisions in Java? Sometimes we pass integer, sometimes we pass a string. We need to check whether the length is fine or not. Sometimes we need to pass a list also here. We need to see if list is empty or not. Or sometimes we need to pass an object and we need to see whether it is null or not. Hence, Java says that why should you even do this much amount of hard work and say that okay, the return type should be boolean. What if I give this to you by default? So they say don't go for function now. Like if you wish you can go, but more better is predicate. So this is our second important functional interface. I'll say Control Shift O, and all those are going to come from this package java.util.function. So this is going to be the case. Now how this predicate looks like, let's see first. So this predicate looks something like this. It just takes the input. You don't need to mention the output. Why? Because it is always going to be a boolean output. The method is test, so you just give input, output is always a boolean. There are few other default methods and the static methods, but again we are not going to discuss them. So let's move on here. We don't need the output this time because it's very clear. So we can just say something like this, and this is going to work fine. Why this is giving error? Because the method is test now. So we'll say test here, and now again if I execute, so this is going to work fine for me. So for such cases, although there is no issue in using function, but it's better to go for predicate. Input can be any data type, output is always a boolean. So this is the one, and again all of them are coming from java.util.function package. Let's move on with the next one and see in demo 3. So in demo 3, if you remember, our scenario was it can accept something, but the output was void. So let's see how to do this one. So I'm copying this, placing it here, and let's check out. So this time, can I do it with the help of predicate? The answer is no, because predicate accepts something but returns a boolean. Here I don't want to return anything, it's a void, so I can't go for predicate. Can I go for function? Let's see. So I'll say function here, and the input I want to keep something as input, so let me keep the input as integer. So this is integer here, and the output, so output I want as void. So can we say void in terms of wrapper? So that V should be capital, so we can write something like this, and the method was apply. So this is apply, and you need to remember all these. So only 3-4 are there, not much. So this is the one. Okay, we have written this, but still it doesn't works for us because it says it cannot return a void result, because this void still means a void result, but in our case we are not returning anything. So this is not going to work for us. So predicate can't work, function can't work. So we need to go for something different. Now just try to do, or just try to think in the common world. What will you call a person who is just going to accept something but not return anything to you? So you can mention that particular word to me in the comments. So usually when I do in some live sessions, I get some hilarious answers for this particular question. So you can also think, what do we call a person who just accepts something but doesn't returns you anything? So I hope you must have written something in the chats, but here let's see whether your answer is going to be same or not. So the term is consumer. We don't need void here. So this is the one, Control Shift O, and we'll go to consumer. So consumer is the functional interface now, which will accept something but will return void. The method name is accept. It's that simple. Consumer is going to accept. It's easy to remember too. So here we will say for this as accept. So this is the one. Once I remember, I asked the same question in my live session and someone said we call that person as greedy, who is just going to accept something and not return anything. But Java can't say greedy, although then it would be even much more funnier. So you see, you are learning still Java 17, so that's good. So this is the consumer, and again what all things you need to remember: the name of interface and the method. So the method is accept, it returns something. It can be any data type, but output is void. Let's move on with the next one. So with the next one, we are here. So this time we are not going to accept anything, but we will just return something as local date time. So let's see how we can replace this one. So we'll go for this test4 here. And what can we write? So again, can we make usage of predicate here? The answer is no. It will always return you Boolean. I want to return a local date time, so not possible. Can I make usage of function here? The answer is no. Function wants something as input. I don't have any input now. Can I make usage of consumer? Again, answer is no, because this time I want reverse of consumer. I don't want to accept, but I just want to return. Now what will you call a person who will not accept something but will always return? You may call something, but Java will call such person as supplier. So the term is supplier, and let's say Control Shift O. Let's see how it looks like. So this looks something like this. It's again a functional interface. This time the method is get. It won't accept anything, it will just return. So this term now represents only the return type, not the input type. So please don't get confused. And since I want to return a local date time, so I can say here like this, local date time, and this should work fine for me. So this is the one, and the method is get. So from supplier I just want to get the things. So again, if I execute, this one works fine for me, and it says this is the date. So now it is 11:26. So you can compare the timings. So this is the one now, supplier. So all these are the 4 important functional interface which we need to remember: function, predicate, consumer, and supplier, and they should be on your tips. Not only the names of interfaces, but the methods also. Do they methods accept something? Do they return something? All this you should remember. They are going to be helpful for your streams also. Hence you can watch this video multiple times and give me views also. Now let's move ahead with our demo 5. Now in demo 5, if you remember, we had something like this. We were having 2 arguments. Now how can Java help us here? Can Java provide us something for this too? Let's see. So let me copy test3, create a test4 class, and this time what I want from Java is that it should be taking 2 arguments and returning me something. So for this, can I make usage of function? So let's see. So if I write here function which looks something like this to me, and this. So if we go here, so this method simply says it will always accept one number, or it will always accept one argument, not a second one. So if we will use function, this is not going to work. But what can be the double of this? Like generally, how can you say this? So there is a term like polar, bipolar. So similarly here the term is function and the other one is BiFunction. So we use the term here bi. So we'll say Control Shift O, and this is the one BiFunction now. So if you open this, there are 3 arguments here, or we can say 3 generics here. So first 2 are the input and the last one is your output. So this is how it works. First 2 input, last is the output. So how we will be writing? We will write something like this. So I want first one input as the integer. Then I want second input also as an integer. They can be same, they can be different. There is no harm in that. And I want output as an integer. So it looks like this. So this is good. And what's the name? So for function it was apply. So for this also the method name is apply itself. So no need to worry much, nothing much to remember. After function, this is BiFunction and the method name is same. The input can be anything. The input data types can also be different. There is nothing like they should be always same. They can be different too. So this is how this worked for us, a BiFunction. Now let's move ahead with the next one, which is our demo 6, and let's see what did we had there. So in the test 4, there we had an operation, 2 inputs, the output is a Boolean. So for Boolean, if you remember, we used to have something like predicate. Predicate always returns us this particular thing, which is a Boolean, and the method name used to be test here. So that also we have written. But the point is, predicate always accept one input. I want to give 2 inputs. So can we say BiPredicate? Luckily, we can say BiPredicate here. Let's open. So this time again it is same. 2 inputs. Both of them are your input only. Output is a Boolean. So BiPredicate is going to work. And currently, in my case, both of them are integers. So this is going to work fine for me. No need to remember method explicitly because it is still test for us. So this is fine. If you wish, I can execute, but there is nothing much with that. The output we will be getting here because 10 is greater than 5. Let's move on with the next one. So the next one is here. So in this one, we again have 2 inputs, but the output is void. So let's check it out. So we'll copy this, we'll paste it out here, and let's go to this test 3. Now this time, for this, if you remember, earlier we made something like consumer. So this time, can we have something like BiConsumer? So let's give it a try. So something like this, it looks fine for us. And if I say BiConsumer, will this work? The answer is yes, it will work. BiConsumer, the method is still accept, the output is void, and this will work. I just need to tell here what are the things. So first one is a string, and second one is an integer. So there is no harm in that, and you can just write it like this, and the method is accept. So this is going to work fine for us. Again, here I don't like this, so I want to write it something like this, a BiConsumer. So this will work fine for us. Now next one, do we have anything like BiSupplier? The answer is no, there is nothing like BiSupplier because in Java you cannot return 2 different things. So there is no need of BiSupplier. That's why if you see, we also didn't made any kind of our own functional interface for that. So if you can't make, how can Java create for you? Now the next question which generally people ask me after this is, what if we have 3 inputs? Then what? Can Java give us something like try? Let's check. So what we will do is, we will just say try, and we will say consumer, and I will say Control Shift O. But the point is, there is nothing like try consumer. So even if I will complete this, although it is giving me error for some other purpose, so even if I will say here like something like this, try consumer, and let's say I will just say here something like null as of now. But in Java, we don't have anything like try consumer, because in that case, we are becoming more greedy than Java. And because then someone say, then I want 3 input, I want 4 input. So that's completely wrong. So Java can help you with 1 and 2. If you want more, then you are always free to create your own functional interfaces. So this is the one. And the general practice why Java doesn't provide us that if there is some such scenario, then we should go for some kind of object. We can create some entity or DTO class, and then we can use again these things only, function or BiFunction and these. Now let's go for demo 8 and let's complete this too with the same way. So what we saw is again something like this. So here we can go for something like BiFunction. So in the BiFunction also, can we have something like this, such a big body? Let's check out. Can BiFunction return or throw me an exception? Let's have a look. So here we are, and this time obviously it's a BiFunction because it is taking 2 inputs and returning some output. So I will try to write here BiFunction, something like this, and the method for the BiFunction is not divide, it is apply. So that is again fine here. And with the BiFunction, let me say the first one is an integer, the second one is an integer, and the third one, that is output, is also an integer. So this is the one. But now the code is not working. Because why is it not working? Because last time, if you remember, IO exception is a checked one. Hence we need to mention the term throws. So when we were using our own operation, we wrote this throws here. Hence when we implemented, it was obvious that it can return an integer or it can throw the IO exception. But with this BiFunction, here we have the method in this particular one. Now here we can't go back to Java and we can't say that okay, I want to throw the IO exception. Hence it is not possible to throw the checked exceptions when we are working with the default functional interfaces. So whenever you are working with any default interface, whether it's a BiFunction, BiConsumer, or something like BiPredicate, or even the normal ones, function, predicate, consumer, or supplier, with them also you cannot throw a checked exception. If you wish, you can throw this unchecked one. So if you wish, you can say something like this, null pointer exception. So this can work fine, and this time it will look something like this if you simply say a null pointer exception, because we are handling this. But if you say an IO exception, which is a checked one, then this one is not going to work fine. Now the point is, what if the requirement comes that we need to throw a checked exception? Then what can we do? So in that case, the solution is that you need to wrap your checked exception in some unchecked exception, which means if this is your main logic, then you need to keep this in a try block, something like this. And see, I'm writing the try block within my body of the Lambda expression. So there we are writing a try block, and there we are going to say this catch. And again for this catch, I know it is going to throw you IO only. So I will write here this IO. Or if you wish, you can even make it more general, or let's say only for IO, because if it is any other exception, then I don't want to bind it like this. So I will say IO exception, and I will say here something like this, exception. And then I will go with the body of this exception here. Now after this I will say like this, throw, but now I want to throw it as a unchecked exception. So for that I will say throw of new, and we know that there is something like runtime exception. So we will say this runtime exception, and we'll write something like this. So what we have basically done is, first of all, we are throwing IO exception from here, that will be caught here as a runtime, and then we are going to throw a runtime exception, and then it will be again caught here and printed. So if I execute this code, it will look something like this. But the problem here is that now our message and other things are lost. So for that we can do something like this. If you are only interested in message, so from your main exception, this one, you can take a message and you can provide here. Let's see how it looks. So this will look like this. Runtime exception cannot divide by 0. But then you may say that, okay, my IO exception is lost. I want to still consider that also into the picture. Then what can we do? So in that case, you can directly put your exception as it is in your runtime exception. Now you see Control Shift O, and let's do a Control Shift F also for the formatting. And now if I execute, it looks to me like this. So we are throwing a runtime exception. Within that we had a IO exception, and the message with IO exception is cannot divide by 0. So this is the way how we can throw a checked exception embedded in an unchecked exception while using the default functional interface. So now let's try to understand what are method references in Java. So they say method references in Java provide a way to refer to an existing method by its name instead of providing a Lambda expression to define the implementation of the method. So this method reference is something even more shorter than your Lambda expression. And here what we are going to do is we are directly going to refer a method only by the instance. This method references are particularly useful when the Lambda expression would only invoke an existing method without performing any additional logic. So in some cases only these method references can be used, not always. So generally we make usage of Lambda expression, but then also there are some particular scenarios where we can make that particular thing even more shorter and we can make usage of method references. So there are some types of these method references. The first one is a static method. So let's say that you want to write a Lambda expression for a static method. So generally what you will do, you will take some kind of input and then you will put some arrow and then you will say class name dot static method name. There you will provide that particular input. So instead of doing all those things, we can just simply say like this, class name and then these two columns. So these two columns represents your method reference. Like your arrow used to represent Lambda, two columns represents your method reference. So this is the one. Second option is when it's not a static but a normal method. In that case, instead of a class name, we can make usage of object reference. Third option is when we are going to refer to some arbitrary object, like for a string. So with the string class, we have generally many methods here. So again, there also we can directly make usage of the class name. And the last one is we can even do it with the constructor. So whenever we do this with a constructor, so let's say I want to say something like new of employee. So I will say employee colon colon new. I want to say new of car. So I will say car colon colon new here. Obviously this is just going to be a default constructor, not a parameterized constructor, because if you remember, the rule was when you just want to invoke the method without performing any additional logic. So nothing extra we want to pass to that method. Only in those scenarios it can be used. So what we are going to do now is we are going to understand all these four with the help of 4 different demos. So let's move to our IDE. So here we are and let's go to demo number 9. So this is a scenario. So first of all, let's just understand the scenario here. So here we have an employee entity class which contains an ID integer, name as a string, marks as again integer. There is a parameterized constructor, then there are some getter methods, and then there is a toString overridden method. I don't need a setter method here, hence I didn't create it, because I will be setting values with the help of parameterized constructor. Now what also I have created is I have created a generator util class. So what this class does to me is here I am having a populate employees method. Whenever I invoke this method, it returns me a list of employees of around something like 6 employees. So here you can see I'm having some employees with random IDs, random names, my name is coming twice, and some random marks are also there. So you see I have not given myself full marks. So this is the thing, and this list will be written. So simply whenever you want, you will get these 6 employees. Simple. I don't want to create the employee list again and again, and hence I did it separately. Now after this, I had something like this demo class here, and in this demo class what I have done is, first of all, I have called that method populate employees with the help of the generator util class. Since it's a static method, I can directly call it with the class name. I am saving the list here. Now I have 2 requirements. First of all, I want to sort it by name, then I want to sort it by marks. So what I'm currently doing is, I'm just having an announced for loop, and I'm just printing it something like this. Direct printing I'm doing. Since I have overridden the toString method, so it is going to print me the contents. So let's see what it does now. Will it be able to sort the things or not? So the answer is, currently it is not sorting. It's neither sorting by name, because first it is Abhishek and then Sneh, then John, Abhishek, Robert, Elisa. Neither it is sorting by marks. 60, 55, 20, 50, 44, 90. There is no order such. So in order to sort a list, what can we use? Now if you remember from our video of collections, there I have mentioned how to do the sorting. So we need something like collections here. So we have collections. So this is a class, not an interface. So this is a collections class which contains a method sort here, and there we can provide our list. So let's provide the list here. So we'll say employee list here. So this is the one, and let's provide the same thing here also for both of them. So this we have done. Now it is still giving the error, because here it says that directly you can't pass on a list. Because if you have seen that video, I have shown you that if you want to pass on the list, so within the list also you need to tell on what basis. Hence today we are not going to use this method, but let's see, do we have any other method? So there is one more method which says you can provide a comparator also here. So what we will do is, we will pass on a comparator here. So currently even I don't know what's a comparator. So what I will do, I will just say new of comparator, because I just want to pass an object. So I will be doing like this, new of comparator, Control Shift O, Control Shift F. This is the one. So let me again check out here. So many times you also will get confused something like this. So let's see how to check and how to resolve the issues at runtime. So here we will go for this, and it says sorts the specified list. All elements in list must be comparable, and it takes something like comparator. And is it providing something to here? So here it is some links. This is the comparator. So can we open this one? So yeah, this is the one which I want, java.util.comparator, and it's generic in nature. So let me try to pass on this particular employee here. So this is generic in nature. Now this particular comparator is the interface. So directly interface you can't provide, so we need to have a body. So what we will do is, we will try to pass a body here like this directly, and here we'll say Control Shift O, Control Shift F. So we have passed on a body, but the body is empty now. So let's again go here, and this time it is going for the right comparator. So we'll say add unimplemented methods. So when we are doing this, it provides me some method like this compare. So it says there is a compare method which you can utilize. So this is the one we have done. Simple. Now let's remove this comment from here and do this. So currently it is saying return 0, and let's do the same thing here also. So we will copy and we will paste this one here. So both 0. Let's see now how it behaves. So now also this is not working. These are not sorted by names, neither these are sorted by marks, because we have not sorted, we are just returning 0. So for this, one option is you can directly write a logic here, and you can directly convert it to a lambda expression, but currently that is not our concern. Our concern is a little different. I want to show you the usage of method references. So instead of directly giving the implementation here, what I'll do is I have created a custom comparator class which looks something like this. It is having two static methods. One is compare by name, where if you pass two employees, it will compare their names, and if you will pass again two employees to this, it will compare their marks. Since it's a static class, static method, you can call them by the class name. Since you don't want to create an object of this, hence I have made a private constructor so that default constructor is not available. So what we will do is we will try to use these methods in that particular comparator. I mean, although I could have used it directly, but my goal is different this time. So let's try to do that. So we will go here and say custom comparator, and we will say here dot, and we will say compare by marks. Okay, so no, first of all we need to compare by name. So let's say compare by name here, and we will keep on passing this O1 and O2. And second time what we will be doing is we will say compare, we will copy this particular thing here, and this time we are going to compare by marks, something like this here. So again it looks fine, and now let's see will this work or not. So let's check out. So here now you can see this is sorted by name, so this is looking good, and these are sorted by marks, so this is again fine now. So this is working, guys, and now you can see what we have done. We directly went for the comparator, it provided me the method, and there I'm using my own custom comparator. There are ways that directly, I mean, you can say why don't we directly use this particular statement here and do the direct comparison instead of calling it. I'm just calling it because I want to show you some other thing with the help of method references. So this we have done. Now what we will do is we will copy this and we will try to convert this to a lambda expression now. So let's do it and try to convert this to a lambda expression. So what we did, we learned that here we can just provide a comparator, so everyone knows, hence there is no need to write it again. Now only compare method needs to be overridden, so no need to again mention that. So let's remove this part. And now we also don't need this brace because this braces was according with the first braces. So let's remove this too and write something like this. Now this is your argument input and this particular part is your body. So let's put a arrow there. So let's say Control Shift F. So it looks something like this. Let's do the, okay, this one is there. Now first complete this one only. Now since there is a single line only, we don't need the braces also, and hence no need of return keyword. So let's remove it. And now again we don't need this braces here, so let's remove that too. Now this semicolon is also looking strange because this time it is within the brackets, so we can remove that also here. And your lambda expression can again look like this. So you see the comparison, how short it has made this thing for you. So earlier you were writing something like this, which was taking your almost 1, 2, 3, 4, 5 and 6 lines, and now it is just a single statement. Let's do same for this. Everyone knows it's a comparator and the method is compare, so let's remove that. And here everyone knows, okay, let me first put a arrow here, okay, and let's remove these braces. Now there is only a single statement, so let's remove this too, and let's remove this particular part also. So this is the short way. Now still we can make it even more shorter. I just forgot it. Everyone knows it's going to be an employee only, so why to write it again? So let's remove this and let's make it even more shorter. So it's upon up to us how short we want to make this. So now this is the short and sweet thing. So the input and this is your output, and we have came here step by step, and let's verify is it working fine. So we can check it out here. So this is still working fine, sorted by name, sorted by marks in the ascending order. And now you don't need multiple lines, so the whole code is covered in 30 lines now, and earlier it used to take around 41 lines. So we have decreased around 11 lines here, so that's a good thing. Now this is your lambda, but we were learning about method references, so let's again have a copy of this. I'm just making a copy so that I can upload all of them together and you can refer to them directly. You don't need to remember that how we reached to that particular stage. So we are here. Now the point is that here these are the input things O1 and O2. And what we are doing is we are just passing this O1 and O2 here. So is it possible that you can pass any extra thing? Like, can you pass something like even? The answer is no. You can only pass O1 and O2. So since we are not doing anything extra, why we are telling again and again that okay, input is O1, O2 and we need to pass O1 and O2 there. So instead of this, let's remove it. So we are removing the input, and since there is no input, so let's remove arrow also. So since we don't have anything there, let's remove from here too. So this also we have removed. Now here, since you are not passing anything, so no need of again these brackets because nothing is passed. Everyone knows whatever is the input, same is going to be the output. So we have removed that too. Now this is your class name and this is your method name. And in order to make it a method reference, instead of a dot, we will say double colon. So if I say Ctrl+Shift+F, this is how your method reference looks like. We can still compare it with this one. So this is a lambda and this is a method reference. And how was that possible? Because whatever we were passing, that is O1 and O2, same was directly used in the arguments. There was nothing extra while passing. Let's try to do the same thing here. We are passing O1, O2. Here also it is accepting O1, O2. So let's remove along with the arrow. Here also let's remove the whole arguments. And between these, let's put 2 semicolon. And let's say Ctrl+Shift+F. So this is how it looks like. Little more interesting. And now if I still execute this, so if I say Java application, this is still working fine for me. Sorting by name and sorting by the marks. Isn't that interesting? So this is your method references for the static methods, where we can make usage of their class names directly, and we just need to have 2 semicolons. Remember, whenever we are using method reference, there is no need of brackets and neither you can write, not even the empty. So this we have seen. Let's go with our next example. So in the next example which we have here, let's see what is waiting for us. So again we have a class employee which is same as the previous one. Then we have generator util, same as the previous one. Then we have custom comparator. Now this is not same as the previous because this time the methods are not static, they are simple methods. Hence we can only call them by creating an object of custom comparator. So this is your demo and this is the thing. Currently if I execute this, it is not sorting them because I'm not using any kind of comparator. So what we will be doing is that we will again go step by step. So let me just put here collections and let me see here sort. If you wish, you can fast forward the video a little bit and directly jump onto the solution, or else if you want to revise, then you can just watch everything step by step again. It's never too late. So we are passing this, but we know this is not going to work, so we need to pass a comparator. So here we said new and then we said here comparator. How did I found I can use a comparator only? Because I went here, I said Ctrl+Shift, then I learned about this particular thing, and from here I came to know this is the comparator which I need to pass, and it's a interface. So same I'm passing here, and it needs to take something like an employee. So this is done and this is the one. So this is your body, and if I hover, it says new of comparator cannot be resolved to a type. Let's say Ctrl+Shift+O. So it has imported it, and now it says add unimplemented methods. So this is the one. Now this is the thing. Ctrl+Shift+F here. We again don't need this. Now this time what I need is I again want to call those things. So let me call. So I will say here compare this, compare by name. I will say copy. I will pass it on here. something like this, and instead of this I will say O1, and instead of this B I will say here O2, and I can call them just by creating an object. So first of all I need to create one, so I will say here custom comparator. Let's call it by the name itself, say custom comparator, and let's say new, and again let's say custom comparator, this one, and this is the way to call. I will copy this, I will paste it here, and I will say like this. So this is the one, custom comparator. Looks good. Now let's convert this here itself to a lambda expression, or if you wish, what I can do is, let's keep it on the same thing here also first, exactly as it is same. Let's copy the same thing, and here let me say marks, and I will upload this one as it is, so that you can see that how we have done this with the help of anonymous inner class. So again, this is your anonymous inner class which we have mentioned here, and let's see if it is working fine or not. So this is working fine, so this is done here, and let me make a copy of it, paste it here, and now let's do the things here to make it short. Now everyone knows it's a new of comparator, the body, the method, so no need of all these things. From here also let me remove one braces. Now we need an arrow between these two things, and this is your particular lambda expression. Since there is only one statement, no need of this return and all, and let me make this also as short. So this is the one. Same, no need of arguments here, so let's make it cut short like this. So these are the things. Let's do the same thing here a little quickly. So what I'll do is I'll quickly remove this, I'll remove this too, I'll remove this too, I'll just put an arrow here, and then I will be removing all these things from here, and from here also let me do something like this, and we say Ctrl Shift F. So we have done the same thing with the help of a lambda expression this time, and I'm not using class name but a variable name this time for this, a reference variable. So this is fine. Now let's try to write a method reference for the same and see how this works. So for this again, whatever I'm passing, same I'm accepting here. So why should pass here? So let's remove, and let's remove from here too. Same let's do for this one, something like this. Now it looks good. Now instead of this dot we'll put a colon, and this we will put a colon, and let's say Ctrl Shift F so that it formats a bit, and this is the one. This time we are writing a method reference, calling the method not by the class name but with the reference which was your second type. So this one is again looking good to us. So let's close that. Hope you have understood it, and let's move on with our third type. So only two types are left, so nothing much to worry, and let's go here. So this is again our employee, looking same. This is generator util, looking bit different. This time we have a populate employees and another method populate names. So what happens is we pass on this list here, and it will just return a list of names. So only names we are getting. And in this demo, first we are populating the employees, and then we are just populating names to a second list. So we just need to sort this one only directly, not the whole object as it is. So let's do that thing quickly. So we'll say here collections, and we'll say this sort and something like this, and let's say here this name list. So we will say this name list here. Now although this will work, but I want to use my custom method, my custom comparator. I want to show you the method reference. So what I will do is, again here also I will say new of comparator, and I will say something like string this time, and then what I wish to write here is these brackets and these things, so that it looks like this, and I wish to override this particular thing and say here where it went, add unimplemented methods. So let's remove all these extra space and this particular part also. So as I said, you don't need to use always the extra thing. You can just say the things here directly. This time we can say o1 dot, let's say o1 dot, and yeah, this is the string, so we don't need to say anything else. So we will just say compare to, and there we'll say o2. That's it. Things should work now for us. Although directly passing a list only should work, we don't even need to write this because it's a string, but we wanted to show something, so this code is working fine for us. So now what we will do is we will copy this and we will try to convert the same thing to a lambda expression. So let's go to this one. Now here let's try to remove all these extra things. So all these things are extra, so let's remove them. From here we don't need these extra braces, so let's remove. This is input, this is your body, so let's separate them like this. Since again it's a single line, so let's remove this too, and let's remove even this particular part. So again Ctrl Shift O. Everyone knows it's a string, so let's remove this part too, but yeah, we need brackets here. So this is the one, your lambda expression. Looks simple. O1 O2 passed, O1 dot compare O2. Now let me just say Ctrl Shift O to remove extra imports, and let's have a copy. Let's try to convert this to a method reference and see how that works. So we will go here. Now again, whatever I'm passing, same I'm using, but this time I'm not using both of the things in my arguments. With one thing I'm calling the method and only one thing I'm passing. So if I will say that I want to remove this completely like this, and hence I don't want to use this also, and then logically O1 also should not be used, but then what can be written? So if I don't want to use O1 here, what can be written? And if I say I want to write O1, then I need to pass it. So for this time I know that I want to use this compare to for the two strings. String is a class, so I will write the class name here, string, and then I will remove the dot and I'll say something like this, string colon colon compare to. So this is your third way. So here, even though the compare to method is not a static method, it's a normal method, but still we can write the method reference like this. Directly if you will try to say string dot compare to and then pass two things, it will never work. But with method reference, something like this can work, and this was your third type. So now also if you see, the things are going to work fine for us. So this was the way. Now let's move on for the fourth and the last type, that is even the last demo for this video. So for this, again we have an employee class. This time it's different. We don't have a parameter as constructor, just a default constructor. There is a generator util method. Now this method is little different this time. Here, as you see, this is not a common method, this is a generic method. Again, if you don't know how to write a generic method, you need to watch my other video on generics. So here what it does is, here we are passing the length, which is generally how many employees we want, and here it is accepting a supplier. So this is the same supplier which we just used in few demos before. So that's the supplier. Now here we will be creating an employer list, and whatever things we will be getting from the supplier, we are using the get method. So in short, we need to pass the object of employee as a supplier now, and if we pass 5 here, so 5 objects will be created. If we pass 10 here, so 10 objects will be created. So this simply tells us how many employee objects are going to be created and how we are going to pass the employee object as a supplier. I could have passed it directly, but I want to show you something, hence I'm doing this way. And this is the thing. So this is just your list and a for loop, but we don't want to create for array list. We want to call this generator util here. So let's copy this name. Let's go for this particular one, generator util, and then let's say here populate employees. So this is how it looks like. Now if I will just execute this, will this work or will it throw me error? So yeah, if I pass here null, then nothing will happen, because if you will pass here null, so there is no issue. And you see, even null pointer exception is not coming. Even though you have passed null here, you are not getting null pointer exception. That's interesting here. So, but we need to pass an object here. So the object which we want to pass. Now how to write a supplier, if you remember. So the code for supplier is, it doesn't takes an input, something like this. Then we need to go for an arrow, something like this. And then we need to give the body. So here in the body we need to give the employee object. So we will say new of employee. Yeah. And then we don't need to write something like this. Okay, we are not passing anything, so let's not write. And here also, when this is the 1, so we don't need write this. I want to write it as a method reference. So after employee I will say colon colon, and then I will say new, and now it will work here. So this is the one, employee colon colon new. And now I remember that why this particular get method was not returning any error, because it was not even entering. The length of the list was 0. So sometimes even we make mistake. So if I say 10 here, it will go there. And then if I will pass null, then obviously it will return me null. But yeah, this is the thing, something which we have learned here now. We are passing employee, then we are saying colon colon, and then we are saying new. So this way we are passing the supplier. So let's see. So 10 employee objects have been passed, and since all of them were created with the help of default constructor, so this is how it looks like. And this way we have learnt the 4th type also for the method references. So that's it with this demo guys, and I hope you have liked this whole video. Now you have learnt about lambdas, not only theoretically, but by now it should be on your tips. Just remember all the functional interfaces which we have learnt here, the method references, and in the next video of streams we are going to utilize all these things which we have learnt here. So if there is any doubt, just go through this whole video again and be prepared for the next video on streams. Thanks everyone.